What is up, people? Today I have an absolute badass for you guys, Juan DeLuna. I got introduced to Juan by a buddy of ours, a mutual friend, Logan Freeman. Shout out to Logan. He mentioned that Juan is the person to talk to when it comes to data centers. And from my perspective, I don't know shit about data centers, and I don't think a lot of people do. So hopefully today is going to add a ton of value. Juan, thank you for joining us. Please give us a brief background on who you are and what you're currently doing now.
Absolutely. Hey, Tan, I appreciate you having me on the call today, and looking forward to the conversation. So essentially, a little background about myself is I've got about 9+ years in the data center industry, roughly about $10 billion worth of infrastructure oversight influence on those projects. Also carry a professional designation through ANSI-BICSI. For those that are familiar, I do have a DC-DC. So essentially, my background's coming from those 9 years of enterprise data center industry works, and essentially supporting those projects through to the finish line. I've worked with around mission critical environments with uptime resiliency, utility reliability, infrastructure planning, which are all non-negotiables, right? When you're in this space. That experience gives Stroff Capital basically the practical perspective on these. Essentially, we do not approach site diligence from purely a real estate viewpoint. We look at it through the lens of the future operations, the utility requirements, infrastructure constraints, and deployment timelines. So frankly, the role here is to help data center developers, off takers, and land developers in this powered land space avoid surprises before they become actual problems. A little background on the market. We source land deals directly from landowners directly, or from commercial companies that come to us, and they essentially kind of want to see if it has data center development potential. On the market opportunity side, it's obvious. The headlines are every day, right? You're probably really familiar with a lot of talk on the news. It's the hyperscalers, AI providers, cloud operators, co-location companies. They're actively seeking capacity, right? But what we're seeing in the market is that the demand is no longer the primary constraint. The constraints are wrapped around power availability, utility timelines, permitting complexity, and even some of the environmental and community acceptance challenges, right? Before you can actually get to becoming the true, accepting the actual true bottlenecks. A parcel may look attractive on paper, but if in this case, if the power delivery is delayed by years, or zoning creates entitlement challenges, or opportunity quickly deteriorates, that's why the site readiness matters more than site availability at this point. Being in the commercial real estate space, Tan, I'm pretty sure that kind of resonates well with you and all the user and the viewers that are watching this podcast, right?
Yeah, 100%. I think it feels like it's one of those where even if you have the land, you can't really make it into a data center, right? It has to have all the bells and whistles that come with that land in order for it to
Right.
be turned into a data center. So even if
Right.
you're sitting on some land, it could be not suitable, or it could be worth dog shit, right?
Right. Yeah. And like I said, we go through about 15 to 20 land deals a week, which is pretty large volume, right? There's a lot of projects and parcels that are never going to meet the criteria, from a standards perspective, and even from a development standpoint. So it's important to note, right? The other thing is, when we talk about across the United States, just for an example, more than 50% of all data center projects across the United States have been significantly delayed or flat out canceled. You start looking at those numbers, that's pretty high. And most of the project failures don't occur during construction. They actually occur much earlier. Community pushback. I routinely see projects struggle because of utility assumptions that they were inaccurate, interconnection timelines that were misunderstood, environmental conditions that weren't fully evaluated, or just entitlement complexities altogether that just weren't properly identified from the beginning. So when it comes to that, whether a site can be eventually developed, the question is whether it can be developed within the required budget and schedule. And that's kind of where we outline and how I handle stuff on the consulting side is, it's a process designed to uncover those issues before any kind of acquisitions or decision makers move forward. And it's more of a decision of confidence or walk away before the costs actually accumulate.
So
Yeah.
are you seeing a lot of outside of the fact that, let's say, you don't have the power infrastructure there? Sometimes there's a cost to actually bringing that power there. But I want to talk about the constraints that you're seeing from like the neighborhood perspective. Like the zoning and permitting and the neighbors just not really wanting a data center to be there. Like currently, we're seeing signs in my neighborhood. I'm in Cincinnati, Ohio, that they're saying like no data centers. Like why is there so much pushback from people for data centers being in the neighborhood?
I'm glad you asked that question. And, frankly, I've told a lot of folks, I said there's two distinct factors here, right? There's the good operators that are not getting talked about, and then the bad operators are the ones that are making the headlines, right? So bad news is always going to sell first, right? And unfortunately, the bad operators are the ones kind of giving the industry a bad name. And a lot of it has to do with, they didn't plan things properly. If, for example, somebody filed for a data center project, and then, it's going to community hearings where there's community involvement and input on those projects. When you don't have certainty around how the project is going to be designed or essentially built out, those become key considerations, right? As far as pushback from the community. For example, there's a lot of red tape and discussion around water, right? Everybody's pushing back and saying, well, they're gonna. One commissioner, I remember, a little while back, they were actually on the news, frankly, and they called data centers a giant refrigerator that swallows up a whole bunch of water. That is far from the truth. I'll say that to some extent, right? Most depending on the way the cooling solution is designed for a data center, and that happens at the very, very beginning stages of what we call program design, right? Where you're kind of figuring out like, okay, I'm doing site selection for a new data center site. Certain markets are going to have different types of cooling strategies that you'll be able to implement for your site, but those should be key consideration items that are done at the site selection stage. And that comes even from the community involvement standpoint. So where I'm getting at here is, if you're in a community where, you've got, a pretty good, zoning board and essentially a good through process on how they handle those entitlements, right? To get you to, pre-construction and construction drawings, and then finally to entitlements. There's a good chance that, if you structure your deal accordingly and you've got all your information in a row, it presents minimal challenges. Now there are some parts even of Ohio that you were talking about. I'm actually working with a project sponsor right now on a deal that is actually in Ohio. But this part of Ohio doesn't have they don't have zoning in this area. So those are kind of things that get eliminated, right? So in that retrospect, it just depends, right? I've seen operators try to go and find land in too much of a rural location, and that heavily influences the design of the data center, right? First you're talking about there's 4-tier rating levels for a data center from Uptime Institute, right? So it goes from tier 1 all the way to tier 4. The higher you go up in tiers, the more expensive that data center is going to be to build. because of the complexities and the redundancies that have to be built into it. But hopefully, I didn't mean. I think I drifted there a little bit on that one, but hopefully it kind of gives you a little more insight on that. So incorporating that design into site selection, along with figuring out what your community involvement is going to look like, definitely impacts your project from the beginning start standpoint, from getting off the ground.
So essentially, when you have a site that's kind of ready to go, or being primed to being built into a data center, you have to have all these things kind of already laid out from a due diligence perspective. If it's well, the biggest thing is probably power, and then the next thing is probably connectivity, and obviously we touched on zoning a little bit. And we're on this slide here on why so many projects fail, and I see that sometimes costs escalate, and that just comes from probably obviously there's construction costs, infrastructure costs, etc. But does the energy costs sometimes jump up on you in some of these?
So yeah, that's an interesting topic, right? So typically what happens is, like, a developer would go and get what's called a load impact study from the utility company, because most times when you're doing site selection and even trying to plan out your power strategy story, there's a lot of different avenues that you can go. Like right now, the quickest right now is always going to be behind the meter for right now, which a lot of folks are going towards natural gas, right, for on-site generation. But to give you an idea, if you were to go do a load impact study on your site, from the nearest substation, that costs you several hundreds of thousands of dollars to get done, and depending on the amount of timeline that it takes, that study itself could take months or even years when you're in the queue waiting for energization, just depending on the market that you're in. So and then even the equipment shortages is another thing, right? Like if you're everybody's trying to do the behind the meter play, and now there's shortages on natural gas turbines and stuff that runs on natural gas, right? So it's a little of everything. When you start putting all the pieces together, right? I've seen projects that get flat out just canceled, and then they've got to move that equipment to another project, or they repurpose it for something else. It's a lot to say the least, on that aspect.
Yeah, it sounds like there's a ton of moving parts here. You kind of have to know the whole life cycle of how energy gets pushed to your site in order to make sure all your ducks are in a row, right?
Yeah, absolutely, absolutely. And the interesting thing is that the markets provided plenty of examples showing that even the sophisticated developers can encounter significant challenges, right? Projects that are backed by some of the largest organizations in the data center industry, they're experiencing delays, withdrawals, and even schedule impacts that are kind of drawing back. So those examples, demonstrate that the capital alone doesn't eliminate the risk, and utility readiness, permitting pathways, infrastructure availability, and local conditions, they all have to be aligned, right? And essentially where we kind of step in, and from my standpoint is, my objective is to kind of help my clientele identify those variables early, so they can make an informed decision about acquisitioning it or going further than reactive corrections later.
That's where you come in. That's the expertise, and
Yeah,
hoping to help these larger developers, or any developer in general, kind of avoid some of these mistakes, because
that's right.
I think some of these mistakes are going to be very, very costly. Am I right?
Oh, yeah, no, expensive, very expensive. I'll give you one example. I had a land developer come to me, and they told me, "Hey, I want to build a data center on this land, and let's try and make it work." And to some extent, I'm looking at it from a standard standpoint. If those discussions kind of had started before they actually purchased the land, and then I think they would have been in a bit of a different position. But that's essentially where Stroft Capital kind of creates the value, right? So before they commit to a site, we help answer their four fundamental questions, right? So can the infrastructure support the intended deployment or project? Are the land constraints that impact the development, right? What does the energy picture look like today and in the future, right? Because that's also an impact if you're utilizing a lot of energy for some of these sites. Now that we're talking about getting on the gigawatt scale, and most importantly, should this site move forward at all? Clearly my goal is to essentially validate every opportunity, but at the same time, both opportunities and the risk, so that capital is allocated intelligently. But yeah, that's essentially where we do that proper site assessment, site selection, assistance, and consulting services. And of course, we go through a lot of deal flow, right? So folks kind of ask them like, hey, how are you able to go through so many deals a week? Well, we've got proprietary solutions that I've essentially built out. I've got a heavy system engineering and IT background. Built a lot of my own tools, automated data centers, and so essentially we basically built a flagship tool that is designed for organizations that need the informed assessment before spending significant money on the land acquisition, engineering, or even the entitlement work. And it focuses primarily on those three core items. The infrastructure analysis reporting, which is a just general high level look of what's going on at a site if you want to pursue it, and then of course a full on land package assessment. And that's where we start kind of getting ingrained onto the standard side of things, and if the site's even going to meet what kind of requirements we're looking at. And I think we touched on some of these tier ratings. Most of what some of the operators that we're seeing is they're kind of having to relay towards this. You hear triple, you hear 5 nines thrown around very very loosely, right? So 5 nines, what that means is downtime of less than about 4 minutes of downtime. From an Uptime Institute standpoint, on the ANSI-BICSI scale as well, as we look at it at a tier 3, tier 4 kind of requirement on the implications, right? One mistake we frequently see with evaluating sites without first understanding the operational requirements for the future facility is figuring out the tier requirement for the site, right? That is going to be one of the driving factors of your data center. Prime example, Tan, I can tell you, I had one land developer come to me. They had a site that was 2 rural. And essentially we started with tier 3 requirements. And then as we got further into, figuring out, okay, what about the intangible costs, like getting skilled labor to the site to do the work, right? Most folks, when they're seeing that, hey, this data center is only employing 35 people, they don't see all the other people that are employed behind that. These data center operators and landlord owners, they're not in the energy business, they're not in the HVAC business. Some of them may be in the energy portion of it when they resell wholesale back to the grid, but that's a whole nother story. For the main part, if you can't get specific skilled labor to the site in time to work on things when they fail, it's going to impact how you're gonna run the site. So in this case, right, that rural site was a little too rural. We couldn't, long story short, we couldn't get an HVAC service company within 5 to 6 hours of the site. That's how rural it was. So when you start looking at the tier rating side of things, you start at a tier 3 requirement, but if you're too rural, now you have to step it up, because if somebody can't get to the site, that's going to impact the reliability and the operations of the data center. And if it if it affects the operations for that data center, then it's going to impact all the tenants that are sitting inside of it. And if you've got SLAs in place, usually when you lease out to tenants and you lease space in a data center, the one thing that throw around is called an SLA, a service level agreement. And essentially in there, it details out, what you're going to be providing as data center landlord, right? What kind of tier rating and redundancy levels are you providing to my site? And if you're not on those on those kind of spars and pecs, even with your facility, you can run into a lot of trouble. But yeah, so there's quite a few items here that you can see on the tier 3 and tier 4. But what you can see is it requires all aspects. It's not just one, right? You could have, for example, somebody could build out a data center and they say, hey, well, I have a tier 3 data center. It has tier 3 power architecture throughout the whole thing. But I have tier 1 cooling. Well, that means that your data center is now rated at the lowest sub-level system that's supporting it. And it's crazy to think about because, like I said, as you go up in these layers, right, once you're up at the tier 3 and even tier 4 level, it gets extremely expensive really, really quick because complexities on how you have to do the redundancy architecture are pretty elaborate. I'll put it that way. Yeah.
So it doesn't even make sense to do like a tier 1 or a tier 2. Like tier 3 and tier 4 is pretty much your only options.
Well, tier 3 and tier 4 is what you're seeing right now from these major hyperscalers. Now, I left tier 1 and tier 2 off only because I see more of the tier 3 and tier 4 requirements with everybody talking about 5 nines. Tier 1 essentially is kind of no redundancy. Tier 2 is you got a little bit of a backup. It's what they call an M+1 kind of architecture. But you kind of start having to draw back on some of these things, right? Like for example, you could have a data center that has UPSs in the middle. Then in the event that your power goes out, the UPSs will kick in and power your data center for a little bit, right? It's not long, on a UPS, right? It's just batteries, but that would give you your +1, right? That would essentially be how you handle it. Now, if you add a generator into this, now you've got the continued redundancy portion of, okay, well, I can bounce the power. The power aspect of it from UPS immediately to generator, and I can run on generator as long as I need to until the grid comes back, right? But those architectures are relatively easy to implement to some extent compared to tier 3 and tier 4. Yeah. So
I got 2 questions for you here.
Sure.
One, the first one comes from you mentioned an SLA, right? Now, me being ignorant of this, it sounds like that with the data center, it means that the tenants are actually someone renting like the compute powering or the computers in and of themselves versus a physical tenant being there. Is that correct?
That's correct. Yep.
Got it.
So
Okay.
Yep. So think about it, just like you've got a retail shopping center. That one retail shop is there. That tenant is essentially your triple net, right? It's kind of in the same fashion here, but essentially the tenant is a tech company, right? They bring their own IT, their servers, their equipment. They put it into your data center. They use your power, they use your cooling infrastructure, and they use your internet infrastructure, your telecom, the fiber optics. Basically that's pretty much what it is. And when it comes to the SLA standpoint from it, Tan, is if we, like, for example, let's say we've got a shopping center and or just a rental, a single family rental, right? And let's say on the contract I said, hey, if there's got to be plumbing repairs that are done to the house, right, or any kind of repairs, frankly, that result in an emergency kind of situation, they need to be redressed within 24 hours, right? It's kind of on that same level, right? But a lot more different. It's a lot more ingrained, right? Not to overcomplicate it, but essentially that's what it is. Your tenant's not going to be too happy if it took 3 or 4 days for you to respond and get somebody out there to fix the problem or whatever it may be, right? In the data center world, that's why they have those tier levels to establish a baseline of what the site is going to provide from a service level agreement standpoint.
And
That's
how often does data center go out, or parts of it go out, in terms of no power or just glitches or what have you?
depending on how the design of the data center was intended, right? Whatever the business intent for that site was, there should be redundancies in place, and if they're not, then of course they affect the whole facility as a whole. Like a data center is what I like to call an ecosystem, and that whole ecosystem has to work together in order to keep it operational and maintained. I've seen for some companies, some data center operators that they have a cooling outage, and they didn't plan for something to take place, whether it was they skipped a preventative maintenance check, or there was something else that was that went faulty, right? And those outage timelines, they could be significant. They could be up to 4, 5, 8 hours, maybe even a whole day. It just depends on how quickly are you able to materialize your business continuity plan for the site, which is another thing every data center operator takes into consideration, right? What am I going to do if something fails, right? There's always got to be something to take place, and most of these, like for example, the HVAC companies, the electrical companies, all these folks, they have on-call folks, right, to get on site to go look at these problems and address them in a timely fashion. A lot of it's industrial equipment, right? So if for example, like that one site that was too rural, right? We couldn't get an HVAC company within 5 to 6 hours in either direction, right? If you didn't design the site accordingly, then, and let's say you designed it for a tier 2 data center instead of a tier 4, then your outage could be significant, right? And bottom line, if I'm the tenant and let's say I'm hosting critical services out of that data center, that's going to impact my customers. Like if I have I guess a streaming service, and I decided to house all my stuff in your data center, and I have people with subscriptions, and then all of a sudden there's a mass outage, and that outage lasts for hours or even days, and then my customers are canceling their subscriptions, and then I have to turn around and say, hey, what happened here? Because those infrastructure investments are expensive, especially when it comes to AI compute chips. We're talking several millions of dollars, right? I've seen it where I have one data center developer that they didn't plan the cooling aspect of it properly, and it led to damages of IT gear, and that gets expensive too, because right now with the shortages of chips and equipment, these manufacturers, the OEMs, are now starting to send out their reps to go check the gear, and they say, okay, well, you want to warranty this? We're going to send our tech out, go do a couple checks real quick. But if they find out that you expose that equipment to improper conditions, as set in the operations manual for their gear, they turn around and void the warranty on the gear. And
Wow.
yeah, and like I said, that's expensive, because now you're talking about a potential lawsuit. You're talking about the tenant coming back and saying, hey, you owe me money for this equipment. But yeah, there's a whole bunch of things that we could tie into. But the other thing is the incentives portion, right? Like there's various states that are offering attractive incentives for data center developers to come in and push capital into these states. It's funny. I had a couple of discussions with some different organizations, and the incentives are often one of the first topics discussed during site selection. But I'm going to tell you right now, the incentives should never be the primary reason a project moves forward, like ever. Because if those incentives disappear tomorrow and your deal didn't pencil to begin with, then you can't start to eliminate the entitlement risk. You can't accelerate the utility timelines. We encourage, our clientele to pressure test every opportunity by asking, a couple simple questions on those incentives, right? Like if they disappeared tomorrow, is the project still going to make sense? If the answer is no, then the underlying business case needs to be further looked at, right? When it comes to incentives.
And what are some incentives that you're seeing that these states are offering to the developers or the
Yes,
data
yeah,
center owners?
yeah. So there's a lot there's lots of there's every state's got different kinds of tax strategies and abatements that they can have. Like one can be hey, we're gonna kind of forego your taxes. We're going to postpone them for a couple years. There's others where they say, hey, we get you tax credits on the equipment that gets put into the data center, right? All sorts of different things, and some states make it really attractive. They put several years on the tax abatements, which make it extremely attractive, right? Property taxes can be very expensive for a data center, right? um, I think the Stargate data center. There was a discussion about that. I think I saw kind of I think a news draft on that one, but they essentially negotiated a discounted, a significantly discounted tax rate for that site. But it all goes to say, right? Like if you're relying strictly on incentives to make your decision to invest in a data center, that's definitely not the way to move forward. And I say that confidently because you think that that's the state's giving all these incentives. That means that everybody's going to cooperate with me. That's not the case, right? And that's essentially where we kind of bringing in that expertise early is going to pay for itself tenfold over, right? And so yeah, every project is going to begin with uncertainty, right? But power assumptions, land conditions, infrastructure requirements, permitting pathways, and even the incentives, structures all to contain risk, right? But those earlier risks are identified, and the more options to exit to address them is the best route, right? We help to evaluate those opportunities before those major capital commitments occur. But yeah, if in short, if you're evaluating land for data center, AI campus, or digital infrastructure project, the best time to perform due diligence is before the agreement is signed, right?
Yeah, 100%.
Yep. So yeah, and that's kind of where we sit in, right? The fast pass assessment, which provides an independent review by somebody with a professional designation, and everything from the infrastructure side of things, and all the way down to even your development risks, right? Yeah, that's pretty much a rundown of what we do, and hopefully that's been valuable. If there's any kind of questions, I'm happy to answer. Maybe it's something that came up in between.
Yeah, so I want to fire a couple at you.
Mm-hmm.
So I personally, I've never stepped into a data center. Is it just like how large are one of these things? I know they talk about like megawatts, gigawatts now, things like that, but from a
Yeah.
square footage perspective, how large are we talking, and like what does it look like in there?
Thousands of square footage. Some of these they call them data halls, and literally it's a data hall. Like they're very large. The depending on the cooling strategy and depending on how they've designed and built it out. You've got certain height requirements on the ceiling aspect of it. You have raised floors in some architectures that are built out. Um, I've seen even some where they have they build the building shell, and then they go and they drop in modular edge data centers, and they slide them in, and they put them in that fashion. It just depends, right? It's when we say data center, the way I look at it is, um, a data center is everything. It's not just the servers and the IT equipment. It's the power infrastructure, the cooling infrastructure, all the supporting gear, the building envelope, the whole thing that makes it into a data center, right? It's you could have a a Mercedes Benz car, right? But if I don't have like certain parts to build this thing, it doesn't become a Mercedes Benz. I could have the tires, Mercedes Benz tires and wheels. I could have a Mercedes Benz steering wheel, but if I don't have all those parts together, it doesn't make the full car. And that's the same thing with the data center. You don't have a data center if you don't have all the key components that make it into a data center.
Sure, sure, absolutely. And let's say I think the correct terminology when we're talking about data centers is, I think we're still in the megawatts unless you're talking about some of the bigger hyperscalers. They're in the gigawatts, right? So
Right. And
it,
and what's interesting about that is, you can get gigs worth of power through behind the meter on-site generation with natural gas. You just have to have the equipment to do it, and essentially the right experts to help you on that. Another thing that's becoming even more prevalent now too is that's being explored is geothermal. That's another avenue as well. But from an open compute standpoint, OPC they kind of were discussing and showing the industry kind of where they want to take things. By about 2030, there's talk that on the per rack level basis, where you've got an actual standard rack, right, that's got equipment and gear in it, they're talking that at the rack level, you're going to be at the 1 megawatt range on power usage, which in comparison to a couple of years ago, that's literally 10x, plus the original requirement. We went from, to think about it, we went from like 30 to 40 kWs. And now we're pushing on the per rack basis level as high as 500 kW. I mean, it's like I said, it's completely 10x. And now we were talking about going towards 1 megawatt on the per rack basis. It's interesting because the complexities that have to be re-architectured to make that happen are very significant. I mean, it's a complete industry change, right, of dynamic. It's kind of like with when they first came out with electric vehicles, right, from Tesla, right. It's a major shift, right. It's a major change, and it's not something that happens quick, especially
yeah,
not
for
with
sure.
industry. So
Like for some of these, we're talking like in the billions, right? To develop them ground up, all in costs and all that.
yep,
And
yep.
how long does it typically take? Probably 2, 3 years to 10 years, maybe.
Well, it depends. It depends on a lot of the things that we talked about earlier. I mean, equipment constraints. It's the power constraints. Like depending on some parts of the country, like you're going to have to wait until about 2030 to get power in some of these states, right? Even if you're in line in the queue right now. Um, there's some powered land projects that have already been through the queue and they're next in line, and those have already been, the upgrades have taken place on, substations and other supporting infrastructure to give you that power, right? So yeah, it's expensive. It's an expensive development for sure, and this is kind of where essentially we kind of shape that as it's what we do is, yeah, we sell preliminary site assessment packages that are very, very quick to make decisions on, whether I put earnest money down on a deal or not. But at the same time, it's more of a decision of confidence, right? Is how my clientele looks at it.
Sure.
I mean, if and like if like, let's say you're doing due diligence for an apartment complex, right? You're probably going to hire a couple companies. You're probably going to spend around probably about 100 grand, maybe a little more than that to get some due diligence, right? Financials checked and make sure your leases and all that stuff are in place the way it's supposed to be. And so it's kind of if you look at it on the same retrospect, you're just considering you're making, if you're looking to make a significant investment, $300 to $400 million, on the front beginning ends. I mean, there should be some certainty attached to it, right?
Yeah, yeah, for sure, definitely. Now, from an operator's perspective, when I was looking at this, I was thinking, it's kind of one of those that you just kind of plug it in, set it and forget it. And once it's up and running, obviously, right? But what does the management look like for these data centers?
Yeah, so sometimes it just depends, right? Some of these sites operate with minimal staffing, right? So it depends how far they've automated the data center, right? So for example, if you look up the AI digital twin that they have for I think it was for NVIDIA's data center, but essentially what they've done is they've created AI agents that effectively can control all of the supporting infrastructure gear, power, cooling, even down all the way to the hardware and chips to optimize the data center. So you start looking at what it used to take before, without AI in the mix. You were looking at about a staffing of at least 60 to about 100 plus people, at a data center. I mean, that's significant staffing, right? But now it's reduced to minimal staffing, which is around 30, right? So depending on the site, they've got 3 different types of shifts, or they'll just they'll have 2 shifts and an on-call shift, right? But like I said, everything is kind of subcontracted out, right? For most of these folks, is they're going to hire like, for example, I've got a generator contact, their company. Essentially, if they're brought in, kind of at the early stages, and let's say a developer decides, hey, I'm gonna use this company for the generator equipment, they actually will go and staff people within 30 minutes of that data center site where that equipment's going to be installed. So it's yeah. So to give you kind of an idea, it just depends on what the operator is trying to accomplish, right? Once you start putting stuff in the data center and it's installed, it's just maintaining the place, right? Things break, right? And you kind of have to be on top of those things, and you still need there's still the personnel behind it that have to make it continuously run, right? It's definitely not a set it and forget it and then walk away kind of thing. You'd be surprised, like the power quality aspect is funny. So there was one data center developer that he was telling me, he's like, man, we made mistakes on the site selection side of things. I was like, yeah, you did. And it's like, so now they're paying for it, right? They had to put in what's called a flywheel system to help condition the dirty power that was being pushed out to the data center. Long story short, they built this data center that was sharing the substation with a heavy manufacturing glue factory. And yeah, that's from a standards perspective, that's a no-no. Like they call it dirty power on the line. And so what that is it's a harmonic distortion that's on the line. So your clean waves are going to look like this, right? When dirty power is on the line, it's very scrambly. And what happens is that dirty power goes into your data center. First thing it's going to do is going to hit those UPSs, and it's going to start messing with those batteries. Before they put that flywheel system in, you were talking they were having to replace batteries like every 6 months, and that's expensive.
I bet.
So
So with like all the AI stuff now, right? AI is pretty much the highest demand for data centers. Are we going to see, if some of these jurisdictions are against data centers and whatnot, are we going to see stuff in, like I think Elon was saying, some AI centers in space or data centers in space or even on Mars, things like that? Where do you see it in the next like 5 to 10 years?
Uh, that's a good question. So the thing that's getting thrown into the mix here, which is quite interesting actually, is the SMR, small nuclear modular reactors, right? That are getting thrown into this. I think the closest one I think is like 2030, 2035 timeframe before that actually kind of gets rolled out and is in use, right? To kind of alleviate some of these power constraint concerns. But I think to an extent, we're going to get to an optimization stage. Is what I foresee, right? Because some of these sites that are being developed, if they had been under construction and, like there's a data center, it's 2 years old, that, folks still want to call it a new data center, but it's not new anymore, right? That technology is already, because of how quickly everything's changing, some of those sites kind of have to be retrofitted, right? As far as this, launching, data centers into space, I'd kind of like to kind of evaluate that a little bit more. I think that's a bit of ways, right? The data center side of things, right? If we're looking at speed, right, on like the fiber optic stuff, right? That's connectivity, right? In space, I'm not saying that hasn't been figured out, right? It's definitely has been figured out, right? It's there's definitely that play there, but I think from an overall standpoint, it's still something that's in the works. I'm all ears. Once they've got a concept to go and push these out. I've seen. I think there's another one where they want to build like these circular globe data centers, and they want to throw them in the ocean and use the waves of the water to generate power to generate the data center. All sorts of innovation is definitely going to come in the next couple of years. Is where I'm getting at this point.
Yeah.
Yeah. So, but not before we hit an optimization period. That's when we're going to see some significant changes to some extent, right?
Sure, sure. Now I want to go over to the investment side a little bit. As I understand it, I think we talked about it previously through Stroff Capital. You work on the investment side a little bit of the data centers as a co-GP, et cetera. For anybody who's a real estate investor like myself, who is typically in strip malls, office, warehouse space, et cetera, how is data center investing different? And I guess what makes it attractive like right now? What do the returns look like and all that?
Yeah, so that's a good question. I'm specifically in the site selection land space, right? Powered land space, which is man, there's definitely a lot of money to be made, and I will also say this: there's a lot of money to be lost. Probably the best way I could say that. If you've got a site that's fully entitled, you've got the power requirements already in place, and you've got everything kind of lined up the way it's supposed to be. You're looking at a significant payday, right? But that doesn't come without the risk, right? We're talking to several millions of dollars um, worth of entitlement risk, and even the power aspect of things kind of have to align correctly, right? And this is where sometimes you'll see developers, from the investment standpoint, and I've been approached by a couple. The understanding of how a data center site selection is handled is much more different than your typical asset classes, right? That are not as tight or as stringent to these types of requirements. For example, if you've got if you're in a place where you don't have that many fiber providers, and let's say they're wholesalers, and in that area, probably not the best place to put a data center, right? It's not in my opinion, it's not worth dropping the millions essentially see something come out of fruition. I've had one developer, there was a fully entitled project that came to them. Um, I told them, here's what a standards review looks like, and I'm gonna leave it at that, right? And it was definitely not favorable, right? By any extent. But again, that's not my decision to make, right? My side of it is, I provide you the consultancy and advisory, and then after that, it's on your part. But there is significant money to be made. I'll say that from that standpoint. You're talking, on the per acre basis, depending on how much power you've got, can range anywhere from, $100,000 an acre all the way to $400,000 an acre. The pricings are varying depending on the market that you're in, right? If you're in a hot market, then guess what? You got gold, right? You're sitting on gold. If you're in a market where there's no data centers and nobody else is around, but you're the only one, there's still money to be made there, but it's risk, right? And depending on your risk tolerance, not everybody's in the space to take a gamble on that. But that's the reason, there's experts, to help you along the way on that. And so yeah, that's essentially where we fill the gap, right? But yeah, great question though.
Oh yeah, absolutely. But unfortunately, my ignorance is running out, so I don't have any other questions for you, Juan.
Sure,
I
no
might have to
worries.
do a lot more research for you, in terms of additional questions and whatnot. But before you leave us, once again, thank you for coming on and sharing your expertise with us. But if people wanted to reach out to you, where could they reach you at via social media, website, etc.?
Yeah, sure. Go ahead and ping me on LinkedIn. Just look me up, Juan DeLuna, and I've got the DCDC at the back of my designation, so I'm not hard to find. Or you can go to our website, stropcapital.com, and drop a contact inquiry, and be more than happy to get in touch with you.
Awesome, Juan. Thank you again for your time, brother. Hopefully I'll get you on at a later time to talk a little bit more once I get my knowledge base up a little bit.
Absolutely. No, absolutely. Yeah, feel free to reach